All right, today we're going behind the curtain of the internet. We're going to look at the hidden machinery that makes all of our favorite apps and websites tick. And, more importantly, how it can be broken, leading to some really massive data breaches.
So let's kick things off with a question that honestly seems a little too simple, right? Can you really hack a website just by messing with its URL? Well, the answer reveals this huge invisible part of the web that security pros are fighting to protect every single day.
To really wrap our heads around that, we've got to look beyond what we can see. Because what you click on, that's just the tip of the iceberg. The real action, the important stuff, is all happening in the background.
And that's where APIs come into play. You know, a great way to think about them is like waiters in a restaurant. You, the customer, tell the waiter what you want from the menu. That's the website. The waiter, or the API, takes your request to the kitchen in the back, gets what you need, and brings it back to you. They are the invisible messengers that make everything work. And this right here, it perfectly splits up the two worlds we're dealing with. You've got the front end, the pretty interface you actually see and interact with, but then you have the back end API, this powerful, invisible engine that's really running the whole show, doing all the heavy lifting with the data. So let's say you're an attacker. Your first move isn't, well, attacking, it's exploring. You first need to draw a map of this entire invisible world before you can even begin to find its weak spots.
Yeah, this whole process has a name, reconnaissance. And it really is like a spy gathering intelligence for a mission. You're looking for blueprints, you're watching the traffic between the front end and back end, and you're identifying every single possible door into the system.
And you would be shocked at how often attackers can find these blueprints just lying around in plain sight. Sometimes developers leave the documentation public, just for convenience. But for an attacker, finding this is like being handed a detailed map of the entire building they're trying to get into.
Okay, so once that map is drawn, it's time to start jiggling the doorknobs and checking the windows. You're not trying to break in just yet. You're just gently probing, seeing if anything is unlocked or, behaves in a way it's not supposed to.
What testers will do is try out all these different commands, or HTTP methods, on a single API entry point. So, for example, an endpoint that's only supposed to get information might have a flaw that allows a delete command to go through. Just think about that. You could potentially delete someone else's account just by sending a different command.
And it's not just about the commands either. They'll try sending data in totally different formats. An API might be built to safely handle one type, like JSON, but be completely exposed if you send that exact same data formatted as XML instead.
And this is where we get to the really clever part. A trick that exploits how a server talks to its own internal private APIs, the ones that were never ever supposed to be seen by the outside world. This is where the real damage can happen.
Yeah, server-side parameter pollution. That's a mouthful for sure, but the idea behind it is just brilliant in its simplicity. You're basically tricking the server that's facing the public into sending a confusing, malicious request to a private backend API, all on your behalf. Okay, let's walk through exactly how this works. Imagine you're on a website, and you use the search bar to look for a user named Peter. The request your browser sends looks pretty simple, nice and clean. But here's what happens behind the scenes. The web server takes your simple request and adds its own little piece of information. Public profile equals true. This is actually a security feature. It's supposed to make sure that the internal API only ever sends back public information. Okay, now here comes the attack. The hacker gets clever with their search term. See that %26? That's just a sneaky way of writing an ampersand, the and symbol, inside a URL. What they're doing is trying to inject a second name parameter, hoping it'll confuse the servers down the line.
So the front-end server, it has no idea what's happening. It just sees the user's messy input and tacks it onto its own security parameter. The result is this polluted request with two completely different name parameters, which then gets sent off to that private backend API.
And this is the magic moment. This is why the whole thing works. The backend API gets this garbled request with two name parameters, and it just gets confused. Depending on what technology it's built with, it might ignore the first parameter, Peter, and instead search for the attacker's parameter, Carlos, completely bypassing the intended security. Okay, so we've just seen how these systems can be broken. The big question now is, how do we build them stronger? How do we defend against these kinds of attacks? Well, the key is that there's no single magic fix. It's all about a layered defense. It means locking down your documentation so you aren't just handing attackers a map. It means using an allow list so that only expected commands are permitted, so a GET request can't suddenly become a delete. And probably most important of all, it means you have to be super skeptical of any data a user sends you.
validating it and encoding it before you ever dream of passing it on to another internal service.
And that really leaves us with a pretty big thought, doesn't it? As these invisible API engines become more and more powerful, running literally our entire digital world, from our family photos to our bank accounts, the job of securing them, of going around and checking all those hidden locks, becomes more critical than it has ever been.